Okay, so we're going to do chapter 6, lesson 2 and 3 together today. So we're going to do similarity for chapter 6, lesson 2 and proving triangles similar for lesson 3. Go ahead and pause here and take these notes. So in this exercise, it's telling us that these two triangles are similar, which means they are the same shape but not the same size. And it wants me to list the sides using the similar symbol. So if I do PM, I would say that is similar to TR. MN is similar to RS, and PN is similar to TS. So when we have these similar triangles, we prove them using our cross multiplies. So for number 1 here, we have MN is 9, RS is 18, NP is 10, ST is X. So I'm going to set it up as 10 over X equals 9 over 18. 9 times X is 9X. 18 times 10 is 180. Divide by 9, and I get X to be 20, which is ST. On number 2, I have NP is 10, ST is 15, TR is 18. TR is 18, PM is X. So it doesn't matter how I do it as long as I keep them in consistent order. So if I do X over 18, then I can do 10 over 15. So 15X equals 180. Divide each side by 15, and X is 12. For perimeters, they are the same setup we can do. So if the perimeter is 30, then MN is 6. RST perimeter is 45. RS is X. So that gives me 30X equals 6 times 45, which is 270. Divide each side by 30, and I get X to be 9. This is just the same setup as we did before, but I'm just going to go down to number 4 here. We have H, I, J, and T, U, V. And if JH is 6 and IJ is 8, TV is X plus 2 and UV is 12. So I just want to do this one because when we set up, we're going to have a distribute problem. So this side is actually going to be 6X plus 12 equal to 8 times 12, which is 96. Subtract 12 to both sides, which gives me 84. And 84 divided by 6 is 14. Now it wants me to do the whole VT, so I have to sub that back in. So 14 plus 2 is actually then 16. Decide if each statement is true or false. All rectangles are similar, which means they're the same shape but different sizes. True. If the vertex of an isosceles triangle is congruent to the vertex of another isosceles triangle, then the triangles are similar. True. Okay, on this one we have HJG, so they went from here down to there. So I have to start at the double angle, triple angle, go to the double angle and the single angle. So EFD, and I have to do the scale factor. So to find the scale factor, we just take one of the sides of the big triangle over one of the sides of the small triangle. So the scale factor is 20 over 15, which reduces down to 4 over 3. This one goes NPM. So they went from the 90 to the 1 mark to the 2 mark. So this would be JKL. And the scale factor then would be 10 is the hypotenuse, so I'd have to use 20, which is 1 over 2. This one is KJML, so I have to do EFHG, and the scale factor is 4 to 5. So next we're going to talk about the similar postulates. So again, the similar, remember, is just same shape, different size. And so there's only 3 of them that we can use. And once we've proved that they are either AA, SSS, or SAS, then we can say they are similar but not congruent. So if I have H and K, and then I have proportional GH to JK, and we use the similar marks instead of the equal marks, so we do them like this. And then HI to KL, that would be similar HGI to KJL because of side, angle, side. This one says M is congruent to QNP, which is this one. R is congruent to Q, and MN is similar to NP, and RN is similar to QP. So I have triangle MRN similar to triangle NQP by angle, angle. On this one I have parallel lines, so I know that Q and M are the same. I know that those are vertical angles, and I only have to have 2 to prove them similar. So M and P is similar to triangle RQP by angle, angle. This one I know that 9 is similar to 18, and 11 is similar to 22, and 7.5 is similar to 15. So triangle VZW is similar to triangle XZY by side, side, side similarity. Okay, on this one we're trying to complete the similarity statements. So we have RX is similar to RS. Then they have RY is similar then to RT. The next one says RX is to XS similar as blank is to YT. So we have RY. The next one said RX plus XS is similar to RX. So then we would say RY plus YT is similar to RY. So this one says if RX is 16 and YT is 12, and RY is 14, then XS is what? So what we're going to figure out here is the similar sides, and we can use this formula we used here. So we have to do RX plus XS, which would be 16 plus X over RX, which is 16, and set that equal to these two added over 14. So this would give me 14x plus 16 times 14, which is 224, equal to 16 times 12 plus 16 times 14, 416. Subtract the 224 to get 192. Divide by 14. To get 13.7. A light pole casts a shadow 24 feet long. So we don't know how tall the light pole is, but it's a 24-foot shadow. At the same time that a 5-foot tall fence post casts a 15-foot shadow. So that would give me 15x equals 120. Divide by 15, and x is 8. Are these triangles similar by the angle postulate? Well, on this one we have parallel lines, which means this is a transversal. So they do share this angle. Angle A. And that's it. So no, they're not similar. This one, if I do the math on this, 90 plus 31 minus 180 is 121. And so no, those are not similar. Okay, on this one we notice that this is our line of reflection here. And so if this is 70, that's 70. And if this is 30, angle 1 is 30. Then we know that 30 plus 70 is 100. So angle A must be 80. And so angle D must be 80. The proportion we would use to find x then is x over 10 equals 9 over 12. So 12x equals 90 and x equals 7.5. Then for y, we would use 6 over y equals 9 over 12. So 9y equals 72. So y equals 8. On this one, notice that they're twisted. The 80s are up there. This is still 30. But 80 plus 30 is 110. So that would leave 70 degrees for angle A and T. And we said the middle angle is 30. And now, because they're flipped, this 21 is actually similar to 14. And the 10, or the y, is similar to the 10. So we'd have 14y equals 210. So y is 15. And then the x is similar to the 6. So I'm just going to use the 21 over 14 again. And then use 6 over x. So 21x equals 84. So x is 4.